In this video, I'd like to show you how to divide rational expressions. Last week we were learning how to multiply rational expressions, and we established these four rules. First, we said to factor the numerator and the denominator of each rational expression, and then even before we multiplied anything, we would eliminate common factors that occurred in both numerator and denominator. And remember, we could eliminate common factors across different fractions at this point. And then when we were finished, we would then combine any leftover factors to create a single fraction. So here's an example. I notice that we have what appears to be a standard trinomial here, so I'll try to create a fraction that has a pair of binomial products. The denominator of this fraction is fine as it is, but I'll write that as a binomial group just to make our factors stand out. In the numerator here, it looks like there's a GCF, and in the denominator here, this looks like another GCF. So since this is a standard trinomial, I'll enter my x's here. I think a factor of 8 and 3 would multiply to make a 24, and also add or subtract to make -5. So I'm going to use a -8 and a +3. And then in the right-hand side, there's a GCF of 4 here. And after I factor a 4, I'm left with x plus 3. And in the denominator, it looks like my GCF is 8x squared. And after factoring that, it leaves me with an x plus 3. So essentially at this point we've completed step 1 and 2, and we factored the numerators and denominators. Now we're going to go ahead and factor out any common factors. This x minus 8 and that x minus 8 are common factors, x plus 3 and x plus 3. There is another x plus 3 factor over here on the left-hand side, but we can't do anything with that since there isn't another factor in the denominator to make that a pair to cancel. So at this point I would consider step number 4 and combine any leftovers, and that would leave us with 4 times x plus 3 in the numerator and 8 times x squared in the denominator. No other factor groups there. And while this is an okay answer, it's not the best answer because I just noticed that the 4 and the 8 could also be factored additionally. So we should always be on the lookout that we factor our results completely. So I'm going to think about the number 4 and the number 8 for just a second. As we practiced last week, sometimes it's beneficial to see these written as prime factors. So 4 would be written as 2 times 2, and 8 could be written as 2 times 2 times 2, and that creates some additional factor pairs that can be eliminated. It looks like we're left with an x plus 3 over 2x squared, and now I would say that that is completely factored. In the example below, we run into some similar problems here. It looks like there's a GCF in this group, a standard trinomial, and there's going to be a GCF here and here. So I recommend that you pause the video at this point and try this on your own. You can resume playback in just a few moments to check your work. We were quite fortunate in this problem in that many of our factors ended up canceling with one another from the numerator and denominator. And it appears that we were only left with this 8 in the numerator and x minus 9 in the denominator. And so that's why I went with a final solution of 8 over x minus 9. For our new content today, we need to practice how we will divide rational expressions. And the only difference here is this new step 1. If you recall from an earlier math course, you should have learned, or you did learn, that multiplication and division are reciprocal functions, or operations, I should say. Now, if I had two numbers, say a and b, then if I needed to have a divided by b as a times 1 over b, or 1 divided by b. So we can reciprocate this second number. We can flip it over itself and turn the problem into a multiplication problem instead of division. And so that's actually what we're going to do here in step 1. Let me show you as an example here. Because if we just follow this new rule number 1, change this division sign to multiplication, and then flip our second fraction, then the remaining steps are exactly the same as what we did for our multiplication problems. So let's see what we get. Our first fraction remains unchanged. Now I'm going to change this from a division problem to a multiplication problem. And since I'm changing the sign, then I need to change this second fraction. I'm just going to flip it over, or reciprocate. And there you have it. I fixed my mistake at the bottom there. Now this becomes a multiplication problem that we should have some comfort in completing at this point. We're going to factor the numerator and the denominator of each fraction and then cancel out any common factors. We had GCF examples in the fraction on the right-hand side, and so that leaves us with this factor group and that factor group that will cancel, the 3 with the 3, and one of these b's can eliminate the other, or one of the b's down here. So I'm going to write that as its prime factors. And now it looks like we're left with 16b divided by 4b. And I didn't catch this just a moment ago, so I'll go ahead and factor this now. This pair of b's can be eliminated. I could have eliminated them back here as well. I just missed it in the last step. But now I also see that 16 and 4, that could actually be factored as well. 16, if you recall, is the product of 4 2's, and 4 is the product of 2 2's. So a pair of these 2's can be eliminated in each case, and we're left with quite simple answer, just the number 4. So the result of this division of fractions is really just the number 4. Let's try one more example. Remember, since this is a division problem, I want to change the division sign and change the second fraction. Then I'll proceed as if this was a multiplication problem. We'll factor the numerator and denominators and then find common factors that will cancel each other out. So here's that fraction, or here's that pair of fractions rewritten now as a multiplication problem. If you haven't paused the video yet, I recommend pausing it now so that you can copy down this step. Now I would recommend that you pause it again so that you can try this next step on your own. You can check your answer with mine in just a moment. And here's the result after our first step of factoring. Now I'm going to look for those common factors that will cancel. N plus 10, we'll take that. N plus 10, 6 and 6, n squared with n squared. And it appears that we're just left with an n squared, or I'm sorry, an n minus 2 in the numerator and 10 times n minus 9 in the denominator. Now I just realized that I think I made a mistake in the last problem. Yeah, it appears that I did. In this numerator, when I was factoring this component, 3b squared was the GCF. And that's what left us with the 2b plus 3. So while that did factor, and the 3 and this 3 factored, only one of the b's from the numerator should have canceled with the b in the denominator. So ultimately that would have left us with an additional b left over here in the numerator, and our final result, instead of being 4, should have been 4b. So kudos to you if you caught my mistake while I was recording. Hopefully you've got a better understanding of that now. So this completes the notes and practice problems for the day. Please let me know if you have any additional questions, and I'll try to address them when I see you next.